First of all, I would like to thank and congratulate TigerGraph community for arranging this hackathon event. My name is Amit Shukla, and I'm very excited to share my open source community project with you today. Religion, sports, and social gatherings bring people together, spread joy and love. Imagine sight of thousands of people taking bath at Holy Ganges or celebrating the Shera together. Being at Lakers game, watching Croatia-France finale in 2018. But sometimes being together can be a nightmare. Ability to predict danger, hazards, and distraction in advance before they do any damage is no longer a distant fantasy. In this AI project, I'm using graph analysis to predict alerts and possibly prevent hazards ahead. This analysis can be used by law enforcement, event management authorities, and applicable to most of the places where efficient crowd gathering management is required. In this documentation, you will see all details regarding problems we are trying to solve. Now we already know what objective of this project is. Let's learn from what we already know. So for example, there are theme parks like Disney, Universal Studio, or Magic Mountain who master and manage crowd gathering so well. So we are going to learn it from their examples. We'll take a section of the map from the Disney or Universal theme park and create graph vertices and edges based on the ride and the crowd gathering they manage. You'll find all the details, all executed examples with real source code included in this documentation. In this project, I have used Julia language as well as the Python to create and mimic the real life data. You will find variety of data sources. So for example, food and supply chain data, visitor data, ride data, all of the data which very resemble to real life data, and I've included all those sample data into the GitHub repository. At the same time, this next section is Internet of Things. So for example, what is the precipitation, humidity, temperature, inside, and what is the density, how to calculate density using a differential calculus, and what we can learn about the existing algorithm, temperature, sound, moisture, all of this contributes, all of these little things contribute in predictions. Once you know the data, next step to figure out the trouble zone. That means depending on the climate, you have to figure it out. You have to find out those early trouble zone indicators. So for example, what is the crowd density? What is the fatal attraction? Is there any interior, is there any transformer or electric circuits located near to the facilities? Are there any extended delays which are more than normal? Or their temperature is like too hot? Things like that are early indicator of any hazards. Let's take an example of the rail tracks. So again, you will see I have created a schema here, and then I have applied all of those trouble zone queries on top of that. So you will find the very real life simple examples here where I'm using IoT data. And if you like this project, please give it a star and do not forget to vote for me. Thank you very much.